Go to newbiehack.com to get the ARM STM32 Beginner, Intermediate, and Advanced kits that includes all the components used in these tutorials, see the growing ARM-based microcontroller tutorials, and check out the very popular AVR microcontroller kits and tutorial series. We're going to be looking at the GPIO input registers, or the registers we need to use to make the input happen. The registers that we use for the input is very similar to the registers we're going to use for the output. In fact, some of them are the same. We're going to look at the mode register, the O-type register, which is the output type register. We probably won't be using that one. The speed register, the pull-up, pull-down register, and one new one is the IDR register. The switch is going to be connected to the input pin. We need to figure out how to get the information from the input pin. We're going to need to know whether there's a 1 or 0 on that pin. Since we need the microcontroller to act on when the pin is 1, we need to figure out how to do that. And the couple ways to do that is by polling it, meaning we're going to test that pin every time we go through the loop. So every time we go through the loop, we're going to test whether there's a 1 on that pin. The other way is using an interrupt. In the interrupt, the microcontroller will tell us automatically, and it will go into another part of the program called subroutine or a method. In this video, we're going to be using the polling method. So let's get started. Let's go into the co-IDE, and we're going to go to Project, New Project. And we're using the STM32 F030R8T6. Click on New Project. We'll call this GPIO Input, a simple input. So later on we'll get into more complex varieties of input. Click Finish. Now we're going to need it's on the next page actually, we're going to need the boot library. Let's add that. And now we have our project. We have our main C here. We have our skeleton code, and we probably know we're going to get an error with that file that is misplaced in the folder. So let's go ahead and build and see what that file is again. And it's the STM32 F0XX HAL config. And we're going to relocate that file into the right location. Right now it's in a test folder, and we'll just put it into the source folder. I'm just going to use the open file just so I get a file explorer. I'm going to go to Components, Kukox Master. I think it's in the boot. Let's see. Yeah, Test. And then I'm going to use the Control C to copy it. And we're going to go back here and go to Source and just put it right here. Control V. It looks like it's already in here. That's weird. Oh, I'm in the wrong folder. Look at that. Let's see. This is the wrong. So you want to just go to the open file. We're going to go to Workspace. Go to our GPIO simple input. Go to Components, Kukox Master, the boot, and the test. This is where the config is located. We'll Control C for copy. Go back to the boot. Go to Source. And under this folder, we'll put it in. So Control V. Now we have it in this folder. We can just cancel this because we don't need this file explorer anymore. And let's do another. It looks like everything is good. This is a warning, so I'm not worried about that. Okay, let's create our pseudocode. We need to include the library. Since we have skeleton code, it really doesn't know how to control the chip, the microcontroller, so we need to include that library in there. Within the main section, and not in the infinite loop, in the main section we need to set up the control registers for the LED output. And we need to set up control registers for the input. And in here, when turn on LED when button is pressed. Okay, so that's a very simplistic pseudocode. We're going to set up the registers. This is where the program enters. This is the entry point of the program. It's going to do some setting up of the output and input. And then we're going to actually do in the loop, we're going to actually test if the button is pressed, and if it is, then we'll turn on the LED. So let's go ahead and put that. If the button is pressed, turn on the LED. If the button is not pressed, turn off the LED. Okay, we don't need this anymore. Alright, so in the output, we need to set up the mode register. We need to set up the O type register, the output. We need to set up the speed register and the pull down register. And then for the input, we need to set up the mode register. For input, let's go ahead and just put for output up here. We don't need to set up the type register, the output type, but we can do the speed register. Actually, no, we don't need the speed register. This is output speed. So it's the mode register and the pull up, pull down. Okay, and the turning on the LED, we've already done that, so we already know that's the BSRR register. Let's put that over here. And then turning off the LED, we can still use the BSRR, but we can also use the BRR register as well. So when the button is pressed, we're going to use the IDR register. This is the input data register. When we're polling this register, it'll have a 1 if the button is pressed and a 0 if it's not, in that specific bit that we're using. Before we forget, we need to set up the RCC, or the reset and clock control. And within this reset and clock control, the advanced high performance bus. And all we're doing is we're enabling the GPIOs that we need for port C, pin 6, and port B, pin 1. Let's go ahead and take care of the port C pin 6, because we've already done that before, so we'll just go ahead and enter that in. We're going to use the AHB member. Oh, we need to include the library because it doesn't know what we're talking about yet. So let's go ahead and do that. Pound include. And it is the STM32 F0XX.H. Alright, I don't think we need that semicolon there. Alright, so let's go ahead and do the reset and clock control. And we'll use the member AHB-ENR, which is the Advanced High Performance Bus Enable Register. And we're going to enable the GPIO C. Okay, so we're going to do that same thing to the B, port B. Alright, we took care of that. The really cool thing about putting in the pseudocode is because they serve as great commenting and annotations within the program, so you know what it does after you've actually put in the code, and it also helps you put in the code. So let's go ahead and set up the control registers. So we'll do the mode register first. So this is going to be under GPIO C, and under that we'll have the mode register. And because we need, well, let's take a look at the data sheet. And let's go to the GPIO registers. Let's go ahead and click that. And we'll have the mode register first. So we need the general purpose output mode, which is a 0 and a 1, and we're doing it to the 6th pin. So that'll be a 0 and a 1. So we're going to put in the 1 first. Actually, I did that backwards, didn't I? It'll be Yeah, that's the 1 here, and then that's the 0 spot. So the first spot would be a 0, and the second spot would be a 1. So in the 0 spot, which is this one, we need a 1. In the 1 spot, which is this one, we need a 0. So let's do the 1 first, which is in the 0 spot. Alright. And then we need a 0 in the 1 spot, so we're going to use an AND and a NOT, as we did in the previous instruction video. So we're ensuring that there's a 0 in this spot. Okay, now the output type. Let's see how that works. In the output type register needs to have it's going to be push-pull in the 6th place. So it's going to be a 0. So we're going to have to use the AND and NOT again. Output type 6. Okay. Now for the speed. Let's see what we need for that one. We're going to have the high speed, so it's a 1 and 1. So that's just going to be 2 ORs. Zero, and we're going to OR 1. Alright. So speed is taken care of. Now the push-pull, or pull-up, pull-down register. And we're going to have no pull-up, pull-down. So we're gonna do an AND NOT with a 1-1. So AND equals NOT GPIO PUPD R. We're gonna go to the number 6. And as we learned last time, if this is a 1 in the 0 place, this is a 1 in the 1 place, and this is a 1 in the 0 and 1 place. So we'll use that, and by doing that we're AND NOTing, making sure there's a 0, 0 there because we're using the NOT. Alright, so let's take care of the input side. So obviously we want the mode to be input. So we want the GPIO B, because we're using port B. And then we're going to go to the mode R register. And let's see what that is in the data sheet. So we want input. So the input mode is 0, 0. So we can use the mode R1, and we can just use the 1 and 1 using the AND NOT, just like we did with the pull up, pull down for the output. So we'll use the AND equals NOT. That should be it. Okay. So now the pull up, pull down is not going to have any pull up, pull down because we're resolving pulling it down externally. So let's go ahead and do that. Let's see how we do that again. Oh yeah, we're doing it the same way we did this one. So AND equals NOT. So just to review, we are setting up our mode for output for the LED. We're setting up our output type to be push-pull. We're setting up our speed register for the highest speed. And we're setting up our pull-up, pull-down as no pull-up, pull-down for the output. In the input, we're setting the mode for output, for input. And we're setting no to pull up, pull down because we're resolving that externally with that 220K resistor going down to ground. Now in the infinite loop, we're going to be using the polling method. So we're going to say if button is pressed, we need it to do something. And we're going to be turning on the LED. And here we'll use the else. We're turning it off. Now what do we need to put in the parentheses here? What is the condition? The condition is we're going to be doing some AND arithmetic, bitwise arithmetic. So let's go over how we do this. The IDR register has 16 bits. Each one represents a single pin. If there is a high digital level on one of the pins, then there will be a 1 in one of these bit positions. We have it on 1, port B, pin 1. And if we press the button and we put a high signal on that pin, there will be a 1 here. If we have no other switches on these other bits, then all of them will be 0. We need to test whether this is going to be 1 or 0. So let's see how we can do that. We're going to use the AND bitwise operation here. We're going to start with the actual register, which is the GPIO BIDR register. And that register is going to have 16 bits in it. So let's go ahead and put in the zeros. Okay, and then we're going to use a mask, which is the GPIO IDR1 register. And that register, or that number, it's not really a register, this is just a number, it's a mask. Let me divide these into 4s. And because we have a 1 here, it's going to have a 1 in the 1 bit place. This is 0, this is 1. Let me just put 0 here. 1, 2, 3, and then so on. So in the non-push button depressed state, this will have a 0 in it. But when we depress the button, it will actually have a 1 here. If we use an AND, this is the AND operation, AND bitwise operation. So we're going to do some AND arithmetic here. So 0 and 0 is 0. 1 and 0 is 0. And then 0 and 0 is 0, and so on. So this would be a false statement, because 0 generally means false and 1 means true when it comes to if statements. To make this come true, obviously we have to press the button, because there'll be a 1 here. So when there's a 1 here, 1 and 1 will equal 1. So that will be a true statement. So by using this mask for this position, which is indicated by this, we can test whether that particular pin and the push button is pressed or not. So let's go see how we do that in code. So we start out with GPIO B IDR. So that's the register. Well, actually no, it's going to be this. So IDR. So this is the actual register that will be listening for the pins to be turning into a 1 or a 0. And it's under GPIO B. And the mask, this is an AND arithmetic. The mask is going to be GPIO IDR. Actually, it's not IDR. It's just IDR1. So that's a little bit easier. So this is the mask. This one has a 1 in that location. And you know that 2 in binary is a 0 and a 1. So the first 2 numbers in this is a 4-digit binary number in hex. So this will have a 0 and a 1. This is actually a 32-bit number here, but it only allows us to use half of it. Because in the data sheet, you notice that all of this is not being used at all. It's only the 0 through 15, which is 16 bits, representing each pin on that port. So now we need to turn on the LED. So we'll use the GPIO C and the BSRR register. And to turn it on, we're going to use the bit set. So we're going to use the OR bitwise operation. GPIO C. No, that's not right. So the bit set register is right here. For number 6, we need number 6. Right here. So we're turning on the LED. Let me put this comment above. Now we need to turn off the LED if this is a false statement. So GPIO C. Let's go ahead and use the BSRR. Why not? We're going to put a 1 in that place for the bit reset. So the bit reset, last time we used the BRR, which is the bit reset register, but we can use the bit set reset register. And you can see it uses all 32 bits. And we use the bit reset for number 6. So we're putting a 0 in that pin if this turns out to be false or we're not pressing the button. Of course, in this simple implementation of code for pressing the button, we're not taking advantage of any debouncing or anything like that, because it's just going to turn on when we're pressing it and holding it down. It'll stay on, and it should turn off when we release it. So it's a very simple implementation of using the button. We'll take a look at more complex situations where we're debouncing and when we're using interrupts to turn it on and off. So let's see if this works. Let's see if it compiles. Looks like it compiled successfully, and that was the first time, which is really good. That's where having these come up automatically really helps when you have the library on. It doesn't mean the code will work, but it means that we don't have any syntactical errors. Let's see if this code works. So let's go ahead and plug in the programmer and program the microcontroller. Let's first hook up the STM32 which is this pin. We can see on the programmer it's the second one down. So it's this yellow one here. SWCLK, the clock, is right here. And that one's the first one, which is the orange. Now the power. This is ground and this is VCC. You can see ground is the third one down. Not the third pin, but the third one down, which is the brown. And the last one is VCC. I'm plugging it into my extension cable. And now I can go ahead and program the microcontroller using this programming button. Okay, the microcontroller was programmed when we press the push button on port B pin 1. You'll see that the LED lights up. So in review, we've set up the LED for output, we've set up the port B pin 1 for input, we installed a push button switch, and we created code to make the port B pin 1 be read by software and turning on an LED and turning off the LED. In the next video, I'll demonstrate the software debouncing aspect of push buttons. Go to newbiehack.com where you can find our ARM and AVR kits. We have kits for beginners, intermediate, and advanced. And also check out the tutorials for the AVR and the ARM series. Thank you for watching.